Hello friends, welcome back my YouTube channel Investments. In this video I will explain sequence of real number. This is the part 1 and I'm going to discuss complete sequence of real number. Before that you can watch my previous videos on basics of real analysis. That is something related to the sets of basics of sets, bounded sets and all, Archimedean property, open set, closed sets. So these all are basics in 6 parts I have covered in my previous videos. You can visit my playlist and watch those videos. Now, in this particular video, I'm going to start sequence of real numbers. And in this video, I will discuss definition and example of sequences, and types of sequence, and then limit point of sequence, Bolzano-Weierstrass theorem, and some important results that I'm going to discuss in this particular video. This will helpful for IIT JAM, GATE and CSIR-NET. My name is Manoj Solanki, and I'm going to start this. If you are getting the concept and like the video, please share and subscribe the channel and press the bell icon for the get notified first. Let's start the topic. So first of all, we are first just to define the definition of function. That is something related to a function. A function is nothing but a mapping, which we have already discussed in the previous video. So the function from natural number, the set of natural number to real number is called a sequence. Okay, this is nothing but a function in which I will put just natural number. It means my domain will be natural number. It will start from n is equals to 1, but it will map anywhere in real number in set of R. That's basically R. Okay, and it is denoted by Sn, An, and Fn. Either it may be the set of real numbers, or it may be the function like set of function also, sequence of function also. Okay, so it is defining by Sn, An, and Fn. Now how is it defining? Like this, for example, I will say Sn, and this is the proper notation of this. So in this particular notation, we'll just define like this. So my sequences are like this. This is S1, S2 up to Sn. Okay, it means we are taking n is equals to 1 to natural number, and these all are entries belonging from natural number. Similarly, if I will write an, then it is nothing but it will be an. Okay, yeah, is this Sn is nothing but a set of sequences. Okay, this is an is going to be a sequence, and that sequence is representing like this. Okay, here it's S1 again a sequence, S2 again a sequence. So this is the notation. Okay, and if it is like this, then A1, A2, A3 up to An. Similarly, if I will write Fn, then it is again going to F1, F2, F3 up to Fn. So these are some notations. Now the examples of sequences, any kind of sequence we can take. For example, n. Now what is this? It is nothing but start from 1. Okay, start from 1. I will put n is equals to 1, then n is equals to 2, then n is equals to 3. It will go up to infinity. Okay, because it is mapping to R. Similarly, 1 by n, if I will write like this, then it is what? 1 by 1, okay, 1 by 2, and then 1 by 3, and go up to 1 by infinity. For example, I can write sine 1 by n. Okay, this is also sequence. How is it sequence? Then it is sine of 1, then it is sine 1 by 2, then it is sine 1 by 3, up to what? Sine 1 by n. Okay, this is the sequence. I can take one more example. For example, minus 1 power n upon n. Okay, so in which it is taking what? If it is 1, then it is minus of 1. Okay, if it is 2, then it will be 1 by 2 positive. If it is 3, then minus 1 by 3. Okay, so it will map up to go up to minus 1 upon n. So these all are the example of sequences, and we'll explore all these sequences in this particular video. So now what is the range of sequence? So if you have any sequence, an is a sequence of real number, then we define the range of sequence such as that numbers are like from where the entries are coming. Okay, it means that range means something like that. If I will take example of a sequence like 1, 1, 1, and this is up to 1. Okay, it will go up to 1 only. Now what is the range in this case? So the range of this an is going to be 1. It means range is something, what? Range is something element of basically those element of codomain whose previous image or pre-imaged is present in the domain. Okay, that's what the definition of range. So here the range is 1. Similarly, if I will write like this, it will be 1, 2, okay, 1, 2, then 1, 2. If I will write 3 again, then 1, 2, 1, 2. So here it is, you can see in range, there are elements 1, 2, and 3. These are in the range. It means what is the output for this? These are the range. Okay. So similarly, if I will take, like 3 will be here also. If I will take one example like this, if it is 1, 2, 3 up to n, what is this? This is the sequence an, and it is denoting like this. We can define like this. Now what is the range in this case? Now in this case, range is nothing but my natural number. So complete, or this so the whole natural number is going to be the range of this particular sequence. Okay, this is all about the example of ranges. Okay, now next, what are some note point on this? Okay, range of a sequence may be finite or infinite. Okay, may be finite or infinite. For example, you can see it is what finite. Okay, we have an example. It is finite, and it is what infinite. We have already discussed. Okay, similarly, terms of sequence are always infinite. Range is finite and infinite, but not empty. See this, but not empty. This one is important. And terms of sequences are infinite. Okay, a sequence will go up to infinite. Because of that, the cardinality of natural number is going to be is like what we are saying, that this one, and this is nothing but infinite. It is like denoting something infinite. So terms in sequence is like terms in sequences are always infinite. Okay, if range of a sequence is finite, then at least one term will repeat infinite time. For example, we have this. So if it is what, if okay, if it is what finite, range of sequence is finite, it means at least one term will repeat infinitely time. So you can see here 1, 2, 3. These are repeating infinitely time. It means at least one. For example, this one. This is also what? This is also what? Finite. And here at least one. It means one itself is repeating infinitely time. So at least one term will repeat infinitely time. If range of sequence is infinite, then only finite many times, okay, repeat only. So terms are repeat only finite many times. For example, here it is what? Infinite. Then one is repeating, one occurs only one time, two occurs only one time, three occurs only one time. It means what? That terms are repeating, or terms are occurring only finite time. Okay, but in this case, here the terms are repeating infinitely time. This is what the important case here. Okay, so next we have types of sequences that we are going to discuss here, and that is something important. So in this types of sequence, first of all, we'll explore what is the constant sequence. So what is the meaning of constant sequence? So if you have any sequence an like this, for example, C1, C2, C3 up to Cn, where all CIs are constant, all CIs are constant, or not all CIs. I'm just going to defining like this: C1, 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 sorry, C, C, C up to C, where C is constant. For example, an is equals to sequence 1 only. This is what? 1, 1 up to 1. This is the constant sequence. Okay, so all the terms, not all terms are constant. Not all terms, obviously, real it is constant, but all terms are single. Only one term will repeat infinitely time. That is what the constant sequence. Okay. Next, we have bounded sequence. It is related to something boundedness of the set. Okay, that we have already discussed. Now it means that if for this sequence there exists a k belonging from real number such that this k will be such that this k, or we can say one k1 and k2 belonging from this. Okay. Okay, yeah, before going to bounded sequence, I will explain what is upper bounded, like bounded above sequence and bounded below sequence. Okay, first I will explain bounded above sequence, and then I will explain bounded below sequence. Bounded below sequence is what? Okay, first bounded above sequence. Bounded above sequence means that, for example, a sequence, for example, there exists a k1 belonging from real number such that each and every element will be less than or equal to that k. Okay, and if it is bounded below, it means there exists a k2 in real number. Each and every element of sequence will be greater than of that k2. Okay, so now what is the meaning of bounded sequence? If these both cases are happening, it means that if a sequence is bounded above and bounded below, then that sequence is going to be bounded sequence. It means each and every element will be great will be less than of k1 and will be greater than of k2 for every, or not for every, there exist k1 and k2 from real number, and these are going to be the upper bounds and lower bounds. That may be supremum and infimum also. Okay, this is what the bounded sequence. For example, bounded sequence is what? Example we can take 1 by n. What is this? It is 1 by 2, and up to what? It is tending to 0. Then this is what? Bounded above with 0. Sorry, bounded below with 0 and bounded above with this. So this one is my k1 and this one is my k2. Okay. Similarly, if I will take n, then it is what? Unbounded. It is unbounded, but it is what? Bounded. Why it is unbounded? Because it will start from 1, 2 and go up to infinity. There does not exist any kind of real number which will be greater than of infinity. Okay, so this is what unbounded. Similarly, you can take okay, minus 1 power n. This is also unbounded. Okay, so these are the some examples. Now we have monotonically increasing sequence. Now what is the meaning of monotonically increasing sequence? It means that if every element is less than of its next element for every n belonging from natural number, or you can say your function is increasing function. Function is what? Increasing function. Let's say let's take one example here. For example, n. So it is what? 1, 2, 3. You can see here what? 1 is less than of 2, 2 is less than of 3. Okay, and again 3 is less than of 4. So it will go up to infinity. So this is what you are monotonically increasing. Again, if you will take n square, it is also what? 1, 4, 9. It is also what? Monotonically increasing. Now next we have monotonically decreasing. Just the same opposite thing. It means that for every next element should be less than of the previous element for every n belonging from natural number, or you can say your function is what? Decreasing function. Let's say minus of n. It means what? Minus 1, minus 2, minus 3, and it will go up to minus infinity. 1 by n. It is what? 1, 1 by 2, 1 by 3, up to 0. Okay, so here it is tending to 0, not up to 0. So it is what? Decreasing. Here you can see 1 by 2 is less than of 1, 1 by 3 is less than of 1 by 2. So these all are the example of monotonically decreasing sequence. Okay, now here we have, yes, we have one next type is strictly monotonically increasing. Strictly monotonically increasing means they should not equal any like there should not any equality here. It means if it is n strictly less than of an plus 1, okay, for every n belonging from natural number. What is the example? This one is strictly increasing, this one is also strictly increasing. Okay, here what is the increasing thing here? We can add example, for example 1 1 2, okay, 3 3 5, okay, 7 7. So this is also monotonically increasing, but not strictly increasing. It is what? Monotonically increasing, but not mono but not strictly monotonic increasing. Okay, so these are the example and this is the difference. Similarly, strictly decreasing means that an plus 1 is strictly less than of an for every n belonging from natural number. For example, minus of n, 1 by n, these are other examples. Okay, this is what about the types of sequences. Now we'll discuss limit point of sequence. What is the limit point of a sequence? That we have already discussed. Limit point of set means if it is making, if it is if there is any cluster, if it is making cluster or the like uh, points, infinite a collection of points, that is called the limit point. It means if you have any sequence and there exists any real number of any real number, L is said to be limit point of that sequence if each neighborhood of L contains infinitely many points. It means what is the neighborhood? This one is if it is containing infinitely many points of that sequence for every epsilon greater than 0, or you can say this thing also, then this will be the if it will be contain infinitely many points, okay, then it is the limit point. Now how is it limit point? Then we'll see what is the limit point here. For example, I have one sequence, okay, I have one sequence that is an is equals to 1 1 and 1. This is the limit point, okay, and it will go up to infinity. Now okay, go up to infinite times 1. Now let's say 1 belongs to, let's say I will take just L. For example, my L is equals to 1. Then I will just write what? L minus, okay, I will just write 1 minus epsilon 1 plus epsilon. Okay, 1 minus epsilon 1. So is 1 containing in this? Yes. Next term is 1 again containing in this 1 minus epsilon. Okay, it means each and every term of sequence. It means each and every term of sequence is containing in between this only. So it means this is belonging from real number. This is my limit point. So 1 is the limit point. Okay, one thing is that if a term of sequence is repeated infinitely time, then it is a limit point. It is also repeating infinitely, and that we'll discuss next. Okay, for example, if I will take one more example here, this is one first example, and if I will take second example like this, for example, a sequence is given that is 1 comma 2 comma 1 comma 2. Now see what is the limit point of this. For example, if I will take L is equals to 1, then it is what? L minus infinite, or let's say 1 minus infinite, 1 minus infinite, 1 plus infinite. So 1 is containing in this, but 2 is not containing in this. But just see whatever. Okay, I can't say 2 is not containing in this. If if epsilon is very small, then I can say, but right now I can't pass any statement. Okay, so how many times this one will repeat in this sequence? It will repeat infinite time, that I can contain that. I can say that in this case also 2 will be belonging from this. If my epsilon is 1, let's say if my epsilon is 3, epsilon may be 3. Okay, it is greater than 0. Epsilon is greater than 0. It can be 3. Then 2 will contain in this. Similarly, if I will write uh, L is equals to 2. If I will write L is equals to 2, then you can see 2 minus epsilon, then 2 plus epsilon. Again in this interval, also all the terms like 1 will contain in this here, 2 will contain in this here. Now you can see here, these both are making the cluster. So 1 will clustering here, 2 will clustering like nearby this interval, this open, this like basically we can say neighborhood, then it is what 1 and 2 are limit points. So from here we can observe that for a sequence, limit point may be more than 1. Here it is what limit point more than 1. For example, okay, we'll conclude all the observation. Okay, for example, if I will take an is equals to 1 by n, it means what 1 by 1, 1 by 2, 1 by 3. Okay, here it is what if I'll take 1 by 1000, then it is what 0.001, then 0.0001, then 0.0001. All these points are just see on number line, just see on number line how it will look like. It is what my 1, it is what 1 by 2, it is what 1 by 3 here. Okay, so let's say it is 1 by 3 here. So it means that these all are point. So this is these all point are here. I'm just giving you the idea of limit point. These all points are making the cluster here. It means if I will zoom it, then it will look like this. Here it is 0. All the points are here. There are infinitely many points. It means this neighborhood, this particular neighborhood, let's say it is my epsilon minus 0 minus epsilon, let's say it is 0 plus epsilon. This is my neighborhood. It is containing infinitely many terms. Okay, here it is not, because there are no negative term. In this particular area, it is containing infinitely many terms of sequence. So that 0 is the limit point. Okay, but see, here my limit point is belonging from sequence. Here also limit point is belonging from sequence. Here limit point is not belonging from the sequence. It means limit point may or may not be belonging from the sequence. It means that we have observed three things. One thing is that if a term is repeated infinitely time, then that will be the limit point. If a term, and second observation from this example, limit point may be more than 1. Next example, limit point is not necessary that it limit point is belonging from the set sequence itself. Okay, so that's what we have some result here. So a limit point of sequence may or may not be belonging from the sequence. That's what the 1 by n. 0 is the limit point. Okay, next we have if a term of sequence is repeated infinitely time, this one, then it is a limit point. For example, 1 2 1 2, you can see the example here. Limit of a sequence is limit that we will discuss in next videos of the limit of the sequence. Limit of a sequence is limit point of sequence, but converts not to. Okay, but converts not to, that we will discuss. Next one is Bolzano-Weierstrass theorem. This one is important theorem because of that it is saying that every bounded sequence has at least one limit point. Using this Bolzano-Weierstrass theorem, I will be able to say every sequence has at least one limit point. Now, how I will justify my answer? Just see. I will be able to say that my sequence, each and every sequence has at least one limit point. Okay. Now, limit point have two cases only. First case is case number 1, that is range is finite, and another case is case number 2, that range is infinite. Okay, I will discuss both the cases. If range is infinite, see, if range is finite, first let's say if range is finite, then at least one term repeats infinitely many times, that we have already discussed in the definition of range. If range is finite, it means at least one term will repeat infinitely many times, and that becomes the limit point of sequence. Okay, in this case limit point exists. Okay, if range is infinite, then by Bolzano-Weierstrass theorem, range infinite, and it is bounded sequence. Range infinite, and it is what? Bounded. Okay, range is infinite and it is bounded, then we can say by Bolzano-Weierstrass theorem that it has at least one limit point. Hence, sequence has a limit point. It means sequence has a limit point. So in both the cases, limit point is existing. Okay. Now we will discuss some questions. Does there exist a sequence with no limit point? Let's just check it. See, here we have discussed sequence has a limit point. Sequence has at least one limit point that we have discussed in this case by Bolzano-Weierstrass theorem. Now the question is, does there exist a sequence which has no limit point? Yes, this sequence. See this 1, 2, and up to n and next. It is not up to n, it is going n to infinity. Now here it is no limit point. So no limit point here. Okay. Next, does there exist a sequence with unique limit point? There will be unique limit point. Yes, 1, 1, 1 that we have already seen. 1 is the only limit point. Okay. Next we have, does there exist a sequence having limit point as set? Yeah, limit point as set 1, 2, 1, 2. This is what limit point is 1 and 2. The set of limit point is known as the derived point, derived set. This is what derived set. It is called set of limit point. Okay. Does there exist a sequence with countable infinite number of limit point? Countable infinite. Yes, countable infinite. That is what the natural number. And we have a sequence. Wait. Yeah, we have a sequence like this: 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, like this. Then what? Set range. The limit point is what? The natural number. Sorry. Yeah, itself. Limit point. Set of limit point. Yeah, set of limit point is nothing but natural number. 1, 2, 3, 4. All are going to be limit point. Does there exist a sequence with uncountable? Yes. For example, if I have 0, 1, 1 by 2, okay, 1 by 2, 1 by 3, 1 by 2, 1 by 3, and if it is 2 by 3, then 3 by 3. Okay, wait. I made a mistake with this. Wait. 0, 1. With this 0, 1, 1 by 2. Okay, then 2 by 2. Then 1 by 3, 2 by 3, and 3 by 3. 1 by 4, 2 by 4, 3 by 4, 4 by 4. Now it is what? 1 is repeating infinitely time. Then what is the limit point? Or uncountable rational number. All the rational numbers are belonging with 0 and 1. 0 and 1 interval. So from here we can say 0, 1, and it is what? Uncountable. Okay, this is the uncountable. This is the example. Now set of limit point of a sequence is closed. That is what the derived set. Okay, set of limit point is what? Let A be a set of all limit points. Okay. A dash. Okay, let's say A dash. Or if A belonging from A dash, this is called derived set. Okay, then A is limit point. Okay, if it is limit point, then what is the definition of limit point here? What is the definition? That A minus epsilon and A plus epsilon contains infinite many terms of sequence. Okay, infinite many terms of sequence. It means A minus epsilon, A plus epsilon is a neighborhood of some limit point. And here what? A minus epsilon, A plus epsilon has infinite many terms of the sequence an. it means A belonging from A. It is what a set, which is called closed set. Just you can see like this. If it is A and it is the derived set of this, my A is coming here inside. Okay, now it is what this one is as A. See, A is inside A is in also A dash. So what is the limit point here? This one is the limit point. This one is result. You can learn it. Okay, next we have one more result, that is set of limit point of bounded set is again bounded and compact. Compact means that it is closed, and if it is bounded and closed, then it will be compact. So this is all about the sequence and its topic that we have discussed. So please like the video, share the video, subscribe, and press the bell icon to get more notification. Thank you. Bye bye.